I think, I don't know, it's good morning or good afternoon, ladies and gentlemen. Thank you very much for your coming, and thanks for Turpin for their good arrangement for this good data that I have seen yesterday and today. I listened to a very informative new technology for railway, and have also attended some for the metro this morning. Excuse me, I'll just go through my presentation for the freight and the challenges that meet the freights. We have in Egypt some special experience with freight because the Egyptian railways is very old. It started since 1850. It comes second after the British Airways. So we have a lot of experience with freight. So when I offered me to speak about this subject, I found myself very much enthusiastic to talk about it. So excuse me, I'll just go for my presentation about the freight. And you will see that I will talk about the high speed, because one of the challenges that meets the freight now is that it cannot meet the high speed passengers, cannot be integrated in the high speed passenger trains right now. The freight trains still moves slower for many reasons. First, for example, in our application in Egypt, that we don't equip all the freight wagons with brake. So sometimes we have one wagon with braking system, and so the braking system is not as efficient as the passenger train, so we cannot operate it at higher speed. Secondly, the heavy loads of the freight. Each tracks have a maximum allowable axial load. So this maximum allowable axial load, the passenger coach is 1/3 the weight of the freight wagon, in addition to the load of the internals of the freight. So the heavy loads of the freight cannot allow to operate it at a higher speed. Otherwise, it could be dangerous, and the tracks cannot withstand the higher loads with the speed. So there are many obstacles that makes the freight to operate at higher speed a real risk. So we'll go through the presentation and see how is now all the world now is talking about the high-speed rail. I think, I'm sorry, they put me the presentation of the signaling at this, I don't know, we thought I'm going to speak about freight. So they put can we change the? I'm sorry, I'm going to speak about this presentation, but tomorrow, for the signaling.
I have this one only.
No, the other one is, I have it in my computer. Ask Nancy. Would you like me to go through the signaling?
If you're comfortable to talk about
No problem. But I'm sorry, because I made the
Sorry, it's the...
Okay, no problem. No problem. So I'm apologize for what did happen. The signaling problem now is one of the hot issues now, and this is subject very have many offers for development nowadays because of also the high speeds. So I'll go through with you about the development and principles of signaling. The signaling the main purpose of the signaling is we want to move the train safely, and control and management of train depends on them. I mean, depends on the traffic, the busy lines, all the circumstances. It started with a very simple system, depends actually on the driver to see ahead. As long as he can see that the line is empty, no train in front of him, he can move. Then, of course, this system was a very elementary system, and it didn't, and it's okay. Yeah. So, some accident, of course, happened because drivers could be upset. He didn't see. He was looking at something, same as we are driving our cars and we just look at the mobile and the accident happened. So these systems, of course, didn't work and problems in experienced. The brake system also is one of the important issues of making the signaling system. For how long distance you need to stop your train? It depends, of course, of the speed the train is moving. Some trains, I mean the fast train, which moves at 200 kilometers per hour, at least needs 1 kilometer to stop. So we cannot tell the driver that stop after 100 meters or something. So all these parameters drive to establish or to develop new system of signaling. Also, the braking system also depends on the steel wheel and the steer rail for traction and braking. So at the end, the train needs a much greater distance to stop. So the next development was to make some time interval between trains. So we dispatch one train, reached full speed. 10 minutes later, we allow the second train to move. So in this, we ensure that there is a 10 minutes or whatever the time interval you want, that the two trains will not catch each other. But again, these problems, this system created another problems. A train break down in the middle, or he slowed down, or something. So this time interval system created serious problem. The speed of the train couldn't be sustained, or would be sufficient to prevent the second catching it. I mean, there was a lot of problems that make this system also subject to accidents. So, line capacity. The line interval also limits the line capacity, because you are limit the line capacity by time interval. For example, within 1 hour you can run 6 trains, regardless whatever the case. You cannot increase the trains by any way because you are working on time interval basis. So this is one of the big advantages of the time interval method. So, fixed signaling, this is the next step is to divide the track into sections and ensure that only one train was allowed in one section at one time. This system still existed in many countries now, although it's elementary, but I think we still have it in Cairo in the less traffic sections. And the fixed signal is what we call the semaphore. The semaphore is divided, one semaphore at each section, one at the entrance, and we can allow one train per section at one time. We will not allow the second train to get inside before the first train will be announced he is out of this section. This is a very safe method, but it depends on the human being. And anything depends totally on human being will be subject also to another problems, and a human being fault is something very possible to happen. Proceed indication, this is what I already explained. Then distance signal. The distance signal means that the basic stop-go signal used was okay as long as the driver of an approaching train was able to see the signal in time to stop. As I mentioned, that the driver needs some time to stop the train, especially if he is in full speed. We cannot tell him, or he cannot show him a signal red and the train in front of him less than the distance required to stop. He will hit him. So the distance signals is corresponding to the distance that the driver needs to stop the train when he sees the signal. And the distance is adjusted based on this minimum distance. Now we'll come to later on that sometimes you need to give the driver an alarm before he stops. I mean, this is all measures taken to ensure the safety and to give the most possible parameters for the driver to stop the train at the time and not hitting the train in front. Positioning depended on the visibility, curvature. This is one, curvature is also very important because sometimes the tracks has a curvature and the driver cannot see the signal. So you have to locate the signal at a place that the driver can see it clearly. This is something relates to the safety of the people inside the train. So this is the reason why we have to be very careful. And all these developments that it will come to, because there are some problems related to the system and they upgraded to tackle or to avoid some problem happened due to the old system. Interlocking is a system that prevents the confusion happens to the train when there are many tracks coming, because some lines have some feeds from sides. So in this case, the system could be confused. So the interlocking, it's exactly like the fail-safe circuit in the electrical. Any problem, any confusion, it interlocks, gives the red signal to the driver, stop. This graph showed us very easily how we can ensure the signaling system. Okay, sorry. The blocks is signals. So in the first block, you'll see the green signal. The green signal means the section is free, no train inside. The second signal shows a red signal. This means that a train. Okay. Thank you. Okay. This is the second signal is red, means that there is a train inside this section. So this train approaching here, he can go. He cannot proceed on this signal unless this train is out of this section and this signal changed from red to light. So this is again a principle of the blocks. Track circuit. The old system depends on a human being and mechanical systems. When the train leaves the blocks, so a mechanical signal is went back to change the signal of the same block from red to green. Now, they did it electrically. Whenever the train is here, so they put a circuit in the track itself. And this is what indicates that a train enters the block. And this electrical circuit is the one is responsible to energize or de-energize the signal before to make it red, or it will make it when this train gets here, he will change this red immediately to red. And this signal will not be changed to green unless this train is out to here. This is all electrical, and it depends on the wheels. The wheels, when it here, it short circuit the circuit, and it energize and de-energize the signal in here. This graph shows how the track circuit block occupied shows when the you see here is of course this is metal, so it short circuit the electrical circuit in here, and this changes the signal to red. So this is of course much better than the mechanical system. In Egypt, in Cairo Alexandria road, we have electrical system because the traffic is very high. In the south lines, which is 1,000 kilometers, it's still mechanical because the traffic density is not that much high to change it. Of course, it's a matter of capital or budget or expenditure. So, but we are in our way to change to all the signaling system to electrical because this is much safer than the mechanical. As I mentioned, because of the speed of the train, so we want the driver to give him an alarm before we give him a red signal immediately. Maybe he is in full speed, so now we give him an alarm. The alarm is the yellow. It's the same principle, but instead of giving him immediately a red signal, we give him the yellow signal. Same as on the street traffic, yellow, red, green. So here is the same principle, but the only difference that we give him an alarm. So in this case, he will start from here, drop his speeds. Again, in our system in Cairo, we have a redundant system, just to be sure that the driver is following the signals, which is what we call it ATC, Automatic Train Control System. The Automatic Train Control System it takes its signal from the red signals here, and it can override the driver. If the driver didn't follow the signals, this automatic train control device will override him. So yellow signal tells him to drop speed from 120 to 80. If he doesn't follow the signal, the automatic train control system will override him and drop the speed. Same with the red system. Also, the red means that he are not allowed to enter this block at all. He has to stop before. The second graph also gives even a more lengthy system for stopping. So it gives two alarms. Sorry. Don't worry, I'll... I didn't bring my glasses, so I have a problem.
Come here. Will these help?
Yeah, sure. This is what we call for aspect signaling, which gives the driver one more alarm signal. Maybe this could be يعني required at higher speed. In our application, we have only one yellow aspect. The safe braking distance is something very important, and it depends on many parameters. In our application, we have the distance 800 meters between each block is 800 meters, and this is the distance required to stop the train from 120 kilometers per hour to 0. Maybe some others needs longer distance. For the freight train, for example, the maximum allowable speed is 80. As I said, they need a longer distance to stop, because not every single freight wagon is equipped with braking system. The overlap is, as I explained before, that the overlap is a distance allowed for the train to stop. It should be past signal showing a stop aspect. If the driver suddenly found a red aspect, and this could happen, so this means that he was on his full speed. So he needs this 800 meter to stop, and this is the minimum distance required to give the driver alarm or to stop, and to keep it the minimum between the train and any clear area in front of him. I tried to give just a very simple presentation of the development of the signaling system from the very early principle of depends on the driver to see in front of him, till lately this electrical system. But now even there are even more advanced system, and there is no signals at all in front of the driver, and all is in front of his panel of computer. Everything now is controlled from his computer. Even the override can come from the computer. So I think we make it easier for him now, because we all know that the train driver, he doesn't actually have a wheel to drive, he only to observe. The main function of the driver is to watch the line in front of him and to stop the train. So now, with the new systems of signaling, all is in front of him in the panel. They're going to give him the maximum allowable speed. They're going to give him an indication what is the area in front of him. Is it clear what will be the next block? Is it clear some train in front of him? And in every system of signaling, you have to have an override system. Because, again, we mentioned that we cannot depend on the driver or a human being on the safety of the passengers. The train now can contain more than 1,500 passengers, for example. So there are always an override system. This comes to end of my presentation, and if any questions, I'll be glad to.
Thank you. Essam, thanks.